Okay, this is a little piece of sulfur here. Little piece, yes.
Just a little bit.
You can see it's got a nice flat surface. I think it's probably been cut by a saw, this one. Now, I have no idea where it came from. It's been here for 1 million years. No, not 1 million years. Probably since 20 or 30 years, maybe. It's been quite a while. It's
Is that old?
native sulfur, as in it's found like that. It's probably come from White Island. Okay. So what I'm going to try and do is demonstrate some of the things we were talking about this morning.
Oh, I heard that.
That piece, Carter, does not fit inside the boiling tube. The first thing I want to try and demonstrate is the relatively low melting point, which shouldn't be too hard to demonstrate. If we could all hear. You remember that's going to be recording there. Your voice is going to be ruining this, you see, Carter. Carter of 5D.
I doubt that.
Burn it to the ground.
Now, with the sulfur melting, you won't see any change in obvious change other than a bit of colour change maybe as it melts. But what I want to try and demonstrate is that idea of the plastic sulfur I talked about before lunch. Okay.
Oh, that's it.
That's the first thing. We don't want to end up burning it and forming lots of sulfur dioxide in here. That's all. I think you can see there's a bit of melting going on in the bottom of there. So we're getting a sort of a yellowy straw-coloured kind of liquid. It's a little bit like urine, really, isn't it? It's not.
Touch that.
And what we're trying to do is melt it and then pour it into the.
It's going red.
It darkens to it goes a reddish colour as it melts, as it turns in from monoclinic into rhombic, or rhombic into monoclinic.
Is that just water still in the beaker or not?
That's just water in the beaker, yeah. Okay, now as we said before lunch, as it gets up to about 400 degrees, it begins to darken up quite a lot, and then if we cool it rapidly, we should be able to get it to form this gooey kind of plasticky stuff, which doesn't last, by the way. It slowly crystallises back and crumbles away, but it's kind of all right while it lasts.
So what's the melting point of sulfur?
The one we discussed just before lunch, 96 degrees.
So it's 96.
No, it's not actually 96, but that's where it changes form. It's a bit higher than that. It's 196 or something like that, isn't it?
So right now
117.
117, there you go.
117 now.
Yeah, oh no, it's more than that, but it's at least that, okay? So it darkens up, and what it does is, and you'll see it there now, see it suddenly became more viscous?
Oh, yeah.
Yeah. Now that means it's really difficult for me to tip this out, but we'll try.
What?
Oh.
How? Like a few seconds ago.
Yeah, what happens is that at a certain temperature the sulfur starts to suddenly become more viscous as it's actually the rings are opening up and joining together, making a big molecule. So I don't know if I'll be able to get that to melt again. So it might be curtains for the water part of it. That's all right, because you can see you saw the sudden change of viscosity. It was shaking around and like that, almost like it crystallised on the spot.
Don't even pour it into the water.
Well, I can't.
Or another try again. Look at some more salt. It's coming down. It's coming down.
Coming down. Oh, hang on, go. It's coming down. Here we go. I could do it the other way, but the glass would just break, of course.
So this is the plastic.
Well, it might be.
Oh, why would the glass break?
If you poured cold water into hot glass, why would it break?
I have no idea.
Really?
Oh,
It's moving.
so what? Oh my God. This is the plastic sulfur.
It might be when it cools suddenly.
Why don't I just put it in the fridge?
It was in the fridge.
How does the fridge get hot?
Check it. Check it.
Hold this. While I get the next one going. Okay, what we're going to do in the other one while that's happening is I'm going to take my deflagrating spoon, all right, for the burning of substances in gesture. Here we go. Whoa.
Hit it, bro. Hit it. Just tap it at the top. It's like honey.
Yes. I personally would prefer honey, but that's up to you. Anyway, while he's busy creating a volcanic lava flow, I'm going to set some sulfur on fire and then put it in this gas jar of pure oxygen. And most of you have
We've already done this, it turns blue.
yes, I know that, but I just want to do the,
Again.
yeah, just to confirm the sulfur dioxide and dichromate reaction, which I think we did in the equation for the other day, didn't we?
Yep.
That's good.
Saying.
My feeling is if we do it twice, there's twice the chance of you remembering it. And still no chance for some of you, but that's all right. Burning? Yep. Oh, isn't that pretty? Is it on the? Got it on the camera there?
Yep.
Doesn't look quite the same on camera, does it? It's better in real life. Now, let's
I thought
Okay.
this is on YouTube.
Video bomb.
Go. Go, Zang.
YouTube.
Oh, it's not.
What?
It hasn't cooled quickly enough. It's set back into solid crystals. Normally it stretches out like this.
Let's see, so can we pass it around?
I can pass it around.
Oh,
yeah.
no.
Don't eat it. Don't eat it, Joy.
Not a jelly bean.
Now, inside this container,
Let's do it again.
we have
Oh, that turns it into
our sulfur dioxide, okay? And we're going to put in that some sulfuric acid.
Broke it.
Can't eat it.
Okay, and our orange dichromate, remember?
Yeah.
Okay, the orange potassium dichromate, which has been acidified with a little bit of sulfuric acid there. Put that in. And very, very rapidly, we've got a green colour there. The ion that's responsible for the green colour is?
Fe3 plus.
Fe2 plus.
Oh my god.
Oh, if yeah.
When I said ion, I meant I-O-N. Tell me, Mr. Choi of 5... No, never. Tell me how potassium dichromate and sulfur dioxide turns into Fe3 plus. This is some sort of alchemy. You just want to be a YouTube star, don't you?
He said
Now
I
he
was
wants to be
like,
another star.
he said I was like, you guys said I was like Fe.
Yes, blame it all on
All
us,
right.
Joy.
It's your fault. Shut up.